Everything that moves will be autonomous. Physical AI will embody robots of every kind, in every industry. 3 computers built by NVIDIA enable a continuous loop of robot AI simulation, training, testing, and real-world experience. Training robots requires huge volumes of data. Internet-scale data provides common sense and reasoning, but robots need action and control data, which is expensive to capture. With blueprints built on NVIDIA Omniverse and Cosmos, developers can generate massive amounts of diverse, synthetic data for training robot policies. First, in Omniverse, developers aggregate real-world sensor or demonstration data according to their different domains, robots, and tasks. Then use Omniverse to condition Cosmos, multiplying the original captures into large volumes of photoreal, diverse data. Developers use Isaac Lab to post-train the robot policies with the augmented dataset. And let the robots learn new skills by cloning behaviors through imitation learning, or through trial and error, with reinforcement learning AI feedback. Practicing in a lab is different than the real world. New policies need to be field-tested. Developers use Omniverse for software and hardware-in-the-loop testing, simulating the policies in a digital twin with real-world environmental dynamics, with domain randomization, physics feedback, and high-fidelity sensor simulation. Real-world operations require multiple robots to work together. Mega, an Omniverse blueprint, lets developers test fleets of post-trained policies at scale. Here, Foxconn tests heterogeneous robots in a virtual NVIDIA Blackwell production facility. As the robot brains execute their missions, they perceive the results of their actions through sensor simulation, then plan their next action. Mega lets developers test many robot policies, enabling the robots to work as a system, whether for spatial reasoning, navigation, mobility, or dexterity. Amazing things are born in simulation. Today, we're introducing NVIDIA Isaac GR00T N1. GR00T N1 is a generalist foundation model for humanoid robots. It's built on the foundations of synthetic data generation and learning in simulation. GR00T N1 features a dual system architecture for thinking fast and slow, inspired by principles of human cognitive processing. The slow thinking system lets the robot perceive and reason about its environment and instructions, and plan the right actions to take. The fast thinking system translates the plan into precise and continuous robot actions. GR00T N1's generalization lets robots manipulate common objects with ease and execute multi-step sequences collaboratively. And with this entire pipeline of synthetic data generation and robot learning, humanoid robot developers can post-train GR00T N1 across multiple embodiments and tasks across many environments. Around the world, in every industry, developers are using NVIDIA's 3 computers to build the next generation of embodied AI.